Hi everyone, my name is Grokhotkov. I'm Vice President of Software Platforms at Espressif. Welcome to the second day of Espressif Developer Conference. My talk today is about ESP-IDF 5.0. Before we get started, let me tell you very briefly about ESP-IDF, just in case you haven't used it yet. ESP-IDF stands for Espressif IoT Development Framework, and it is an SDK for building IoT applications for Espressif chips. It is not the only software framework for Espressif chips, but ESP-IDF is the project where we first introduce support for all new chips and chip products that we release. ESP-IDF is an open source project with many active contributors both inside and outside Espressif. And it is also a foundation for many other Espressif software frameworks, applications, and solutions. Now that I've briefly introduced IDF, I will tell you about the purpose of this talk. We will start with an overview of IDF release and maintenance policy, and also look at the status of the currently available releases. Then we will cover important changes in 5.0 that you need to keep in mind if you're upgrading, and I will also give you some of the reasons why you should consider upgrading. Finally, I will mention a few things coming to IDF in the future. And by the end of this talk, I hope that you will know enough about IDF 5.0 to apply it in your projects. So since 2016, when we released the first version of IDF, there have been 66 releases of IDF project. When releasing a new version, we use semantic versioning model, and this model defines the meaning of release numbers. In semantic versioning, the release number contains three components: major, minor, and patch. The patch component of the release number is incremented to indicate that the release contains bug fixes. The minor component of the release number gets incremented to indicate that the release may contain bug fixes and new features, and the major number is incremented that, aside from new features and bug fixes, the release may also contain breaking changes. Now, semantic versioning describes how to interpret the release numbers, but it doesn't define which release numbers the project will actually use. To meet the needs of our users, IDF maintains a release branch for every minor version, and I will explain what that means in a moment. The lines in this graph show branches in ESP-IDF Git repository. The development primarily happens on the master branch. This is where only features are implemented and where the fixes are made. The circles on this graph are releases. The bigger ones are minor releases, the filled one is the major release, and the smaller ones are bug fix releases. For each major.minor version, for example 4.4, we maintain a release branch. And release branch is necessary to make bug fix releases for a given minor version. So release v4.4 is the branch which we use to make bug fixes for v4.4. For example, v4.4.1 and v4.4.2 are the two bug fix releases on this branch. Unlike master, development on release branches primarily occurs using so-called backports. And a backport is the term we use for taking the changes that were previously done on the master branch and then applying them to one of the older release branches. And this is done using Git rebase or Git cherry pick. So this illustration is simplified because the positions of the circles on the horizontal axis on the timeline, it doesn't actually match what it was in reality. This illustration is just to explain the concept of release branches and bug fix releases that happen on those branches. Normally, we only backport bug fixes into previous release branches, and normally we don't backport features. Sometimes, however, we do backport features when several conditions are met. First of all, the risk of regressions from backporting the feature is considered low, and also if the feature is relatively self-contained. One case when this happens is when introducing support for new chips. It is very common that a new minor release of ESP-IDF adds support for one of our new chips. However, in the first release, not all features of the chip are implemented yet. In this case, subsequent bug fix releases on the given branch may add support for the missing features for the chip which was supported on that branch. Doesn't mean that every feature will be supported, but typically some features will be added in subsequent bug fix releases. However, even if we consider fixes, not every fix will be backported to all the release branches. So to understand when we backport a specific fix and to which branches we backport it, we have to talk about the IDF support period policy. The latest version of IDF support period policy was introduced together with IDF 4.1 release. Under this policy, every release branch is maintained for 2.5 years. This 2.5-year period is split between a 1-year service period and a 1.5-year maintenance period. During the service period, since the release of the first release of this branch, so the certain major.minor version, this release branch is recommended for new designs. So if you're making a new product, then look at the supported releases and pick a release that is in the service period. If your development timeline is longer, you may want to look at one of the branches that hasn't reached support period yet. So for example, one of the pre-release branches. However, for typical development timelines, pick the release that is in the service period. During the service period, we try to fix most of the bugs that are found in this release and backport them to that release branch. We also sometimes may backport some of the features for the newly introduced chips. The subsequent 1.5-year maintenance period is when we only backport high-severity bug fixes and security fixes. So in this 1.5-year period, the branch is no longer recommended for new designs. If you have an existing product which is based on this branch, you can continue using it, but this is the period where there will be less support provided for this branch. And as you go closer to the end of the maintenance period, you should consider upgrading to one of the supported branches so that you don't end up using an end-of-life release. If we look at another graph, and this is the graph you can find on the front page of ESP-IDF project on GitHub, you can see how these support periods are aligned right now. For example, as of now, the 4.4 release is in service and the rest of the releases are in their maintenance periods. So if you're starting developing for a new product, then 4.4 at the moment is the release you want to develop with. However, a 5.0 release is close, so if your product development is only starting just right now, you may want to consider using the 5.0 release, and this is going to be what we will talk about the rest of the talk. Here is another way how we can look at the current support periods of the release branches. In this table, you can see what is the latest bug fix release for each of the branches. And keep in mind that if you're watching this talk later, this table probably will get out of date. So check ESP-IDF GitHub repository for the list of latest releases. Now, if we look back at this diagram, suppose you have a product based, say, on version 4.3.1. When the new release comes out, should you upgrade? Should you upgrade, for instance, to 4.3.2 or 4.4.1 or 5.0? So let's talk for a second about what to expect when upgrading to a new release. If you are upgrading to bug fix releases, what you expect are fixes for security, stability, and performance. Sometimes, if you're using a newly introduced chip, you may also expect certain features to be added in a bug fix release. If you are upgrading to a minor release, typically upgrading to minor release is more work because more changes might happen. And for example, the release notes for minor releases are typically longer than for bug fix releases. So you need to check more things when upgrading. The reasons to upgrade to a minor release typically are to get new chip support, to get new features introduced in this release, and to avoid using an end-of-life release. So for example, if you're on a branch that is already in the maintenance period, you may want to upgrade to the branch which is in the service period to avoid using an end-of-life release. And that would mean upgrading to one of the next minor releases. And finally, what does it mean to upgrade to the next major release? Typically, the motivation is similar for upgrading to a minor release, so get new chip support, get new features, avoid using end-of-life release, but there is higher effort to upgrade. And this is because of the break-in changes. So let us talk about the break-in changes next. ESP-IDF aims to maintain source-level compatibility between releases. What this means is that if you have a project that could be compiled and would run correctly with the previous version of ESP-IDF, then if you compile it with the next version of ESP-IDF and you run it, it would behave correctly as well. So anything that prevents that correct operation would be considered as a break-in change. We try to avoid break-in changes to not violate semantic versioning in bug fix and minor releases. Sometimes, however, break-in changes still occur, and this happens primarily for two reasons. One is that sometimes break-in change is necessary to fix some higher severity issue. For example, a certain security issue might be fixed by making a break-in change. So let's say a certain cipher or a certain cryptographic protocol that is now considered insecure might be disabled by default in one of the new bug fix or minor releases. And technically that would be a break-in change, but this is a break-in change that is aimed at improving security, and this is why we still make it. Other category of the break-in change is unintentional break-in changes. So unintentional break-in changes occur when we miss certain way in which an API can be used, or we miss a reason why the change would be a break-in change when doing code review. It is easier to notice break-in changes in APIs, like changes to function signatures or changes to names. It is more difficult to notice break-in changes that are behavioral changes. So something that used to work in a certain way, an API that used to produce a certain result, it might start behaving differently in a new version, and this is sometimes what we miss during code review. So in this case, we appreciate reports or issues on our ESP-IDF GitHub repository. If we find some, if the users find some break-in change, then typically we try to fix it in the next bug fix release. So more information on API stability you can find in the API stability page of the ESP-IDF programming guide. So now that we talked about the break-in changes in general, let's move on to the main topic, and that is the 5.0. So break-in changes in 5.0 have been, break-in changes in 5.0 can be broken down into three categories. So first is the changes that we just couldn't implement in a non-break-in way. And therefore, we were waiting for a major release to introduce those break-in changes. For instance, this is the change of the time t-type from 32-bit to 64-bit, which we did in 5.0, and I'm going to tell about this later. So in this case, essentially the feature or the change itself requires to make a break-in change, and therefore it has to happen in a major release. Another category of changes are some changes that we do to make development and maintenance of ESP-IDF possible in the future. So this is cleaning up or removing APIs that have been previously deprecated, improving naming and code structure, improving some design like adding return values or fixing bad API decisions that we've done in the past. And finally, the last category is switching to safer or more secure defaults. So that includes, for instance, the example that I gave with security. So if a certain protocol or a certain method is considered insecure, then changing the default to a different method that is considered more secure might be a break-in change, but it is an example of what we could do in a major release. Another change in 5.0 is that we have started actually collecting the list of changes in the migration guides section of the IDF programming guide. In the previous releases, we only mentioned the break-in changes in the release notes, but release notes are already quite long and it's sometimes pretty easy to miss something there. So putting the break-in changes and the migration instructions for those changes into the programming guide hopefully will allow you to find how to upgrade to this release easier. So we will continue maintaining this migration guide section in the future, and in the programming guide you will be able to find entries, for example, migrating from IDF 4.4 to IDF 5, migrating from IDF 5.0 to 5.1, and so on. So now on to the major changes in 5.0. I listed here several categories. Most of the changes I'm going to be talking about, or actually all the changes I'm going to be talking about, they are mentioned in the migration guides section of the programming guide. So if you want more details about one of those changes, please take a look at the programming guide. These changes that I'm going to talk about, they're arranged in several categories, and I'm going to start with probably the most noticeable one, and that is the components that ESP-IDF actually contains. Previously, when developing ESP-IDF, when introducing a new major version or minor version of ESP-IDF, we would often add new components. The new components typically provided some additional functionality, additional features, support for more protocols, libraries, peripherals, and so on. ESP-IDF 5.0 is here notable because it's the first release where we actually removed components. Here is a list of components that have been removed. Primarily those components, we consider them to be relatively high level, so not very close to hardware. And these components, for instance, the libsodium is a cryptographic library, Seaboard, Jasmine, and XPath are protocol parsers, NGHTTP, SH2lib, CoAP, also protocol-related libraries, ESP modem, MDNS, ESP WebSocket clients, ASIO, also protocol-related, and free Modbus. It's a Modbus library now, we call it ESP Modbus. These libraries, and also several other libraries that have been present as components inside examples folder of ESP-IDF, are now no longer available in ESP-IDF. But that doesn't mean that you can't use them. So these components are now maintained in other repositories under Espressif GitHub organization. For example, we have IDF extra components, which contains many of those that I have mentioned. Also ESP protocols, ESP Modbus, and several other repositories. The reason why we have moved these components out of ESP-IDF is to make the release cycles of these components independent of ESP-IDF. At the moment, you would have to wait for the next ESP-IDF bug fix release if you want to upgrade one of those libraries to the next version. So it means that we couldn't release bug fixes or features for those components quickly enough. Now that these components are outside of ESP-IDF, they can have separate release cycles, and we can release bug fix releases as often as necessary. And you don't have to wait for the next IDF release if you just want to upgrade one of those components. These components can be found at our component registry, components.espressif.com, and they can be easily added to the project using the IDF component manager and IDF-PY add dependency command like shown here. ESP-IDF component manager is one of the major features that we are introducing and relying on in IDF 5.0. There is another talk at developer conference about component manager. I encourage you to watch it. I think it's one of the really nice features that we are adding. The second category of major changes that I'm going to talk about is related to header files and APIs. You will probably notice this if you're trying to build existing code that was written for IDF 4.x or 3.x even with IDF 5. So it will typically show up as some unresolved inclusions, missing declaration of some functions, and missing declaration of some identifiers. The reasons for those errors or compiler warnings would be because some header files have been restructured. First, we have cleaned up some implicit dependencies between header files. A couple examples here. ESP system is a header file that previously used to include a lot of system-related functions. Subsequently, in IDF 4.3, I think, we have moved some of those functions into more specialized header files. For example, random number generation was moved from ESP system to ESP random. But for compatibility, because IDF 4.3 was a minor release, ESP system would still include ESP random, so that including ESP system, you would still get declarations of those functions. Now that we are in IDF 5.0, we had a chance to clean this up, and now ESP system includes just the bare minimum, and ESP random, ESP mag, and ESP chip info are separate. Another example here is that FreeRTOS header files, which commonly are included in a lot of source files in IDF and in user projects. FreeRTOS header files used to include a lot of header files from other components of ESP-IDF. For example, including any FreeRTOS header would also result in inclusion of a header file ESP-timer.h. And that meant that you could use ESP-timer functions like ESP-timer get time without actually having include ESP-timer.h in your source file. And this actually also led to problems that we couldn't break the dependency of FreeRTOS on ESP-timer because of those implicit includes. So in 5.0, this is being cleaned up, and now FreeRTOS header files no longer include ESP-timer.h. So if you use some ESP-timer function and you haven't added this include into your source file, you will need to add it. The final category of those changes to header files and APIs are some typo fixes, for example, something that previously used to be called ESP-JTT encrypted MITM. So with the missing T, the typo was now fixed, and the name is now correct. This is something that we do in 5.0 just to clean up those APIs, and so that in the future, if you stumble on those names, they will look more reasonable. Now moving on to the next category, and that is the toolchain. In 5.0, we are upgrading GCC to one of the newer releases. Previously, IDF 4.x have been using GCC 8.4. Now we are moving on to GCC 11.2. That by itself can be a break and change for some of the applications, because GCC now produces more compilation warnings and compilation errors in this more recent release. So GCC notices more problems in the code that will manifest themselves as warnings or errors. So depending on your project's settings for compilation warnings, you may get new warnings or new compilation errors, and the best recommendation here is to actually go through them and try to fix them. Although compiler does sometimes produce false positives, warnings, or well, rarely errors, it is usually better to make the compiler happy, and that typically results in a better quality code. We have the GCC release notes and migration guides linked from IDF migration guides, so check out the programming guide, the migration guide section, and you will find the changes that you may need to do from the GCC perspective. I also already mentioned the time T change, so that is to resolve the year 2038 problem. In 2038, the 32-bit Unix epoch time T will overflow, so the software needs to upgrade to 64-bit time T type. This has been requested a long time ago, but we couldn't make this change in a non-breaking way, so this had to wait until the major release. And now with 5.0, we are finally switching the default type to 64-bit. So this probably will not actually cause breaking changes to most of the applications, but if you're dealing with time T, like doing some conversions or arithmetic, you need to check whether you are mixing any 32-bit type anywhere accidentally. And the last two changes in the toolchain area, they're kind of related. This is related to the way uint32t and int32t types are defined. Previously in 4.x releases, the way those types were defined was actually different for Extensa and RISC-V architecture. For example, on Extensa, uint30t was defined as unsigned int, and for RISC-V it was defined unsigned long. So we are unifying this, and in 5.x, this type will be defined the same way as unsigned long, both for Extensa and RISC-V. And actually, this is also the way this type is defined in upstream GCC for 32-bit ARM RISC-V Extensa architectures. So we are just removing this behavior that in Espressif toolchains, Espressif Extensa toolchains, uint32 has been defined as unsigned in the past. However, do note that other compilers like CLang, for instance, define uint32 as unsigned int still. So this is something that you have to be careful in your applications when writing the code to not make assumptions about the way uint32t is defined. The practical way this manifests in most applications is through format string errors. For example, in this code, if you're printing out an int32t value using the %x modifier, format specifier, then when upgrading to IDF5, you will get the warning or the error actually that is shown here. So the compiler will tell you that the format specifier says unsigned int, but actually int32t is a long. So, and long to int conversion cannot be done implicitly, well, in the case of format specifiers. So the compiler asks you to change this to %lx. Now, the recommended way to solve this is to use the header file called inttypes.h, and this header file provides macros like here shown prix32, which expands to the correct format specifier for the 32-bit fixed width type in 32t and with a hexadecimal representation, so x. Using this format macro prix32 will work correctly with every compiler, with every IDF release, and this change is backwards compatible as well. So if you have a project that needs to be built both for IDF 4.x and IDF 5.x, this way, if you change it this way, it will be built successfully. So now on to the next category of changes, the build system. The most noticeable change here is that we are finally removing the support for legacy GNU make based build system. This build system has been the default for IDF since IDF 1.0 to IDF 3.3. In IDF 4.0, we have introduced CMake based build system, and make based build system was made legacy. And in this release, in 5.0, the make based build system is removed. If you still have a project that has been used in the make-based build system, you can upgrade it to CMake using the script that we provide. This script you can run in any of IDF 4.x releases, and it will try to convert your make-based project to CMake. It will work primarily for simpler projects that stick to ESP-IDF build system usage, as we show in the examples. If you have some very complex or custom component, then you will have to upgrade to the CMake based build system yourself. If you have been using other chips than ESP32, so ESP32S2, ESP32S3, or ESP32C3, then it means you are already using CMake based build system, and there is nothing to worry about. Only ESP32 was supported in the legacy GNU make based build system. The second change here that you probably will also run into when upgrading to IDF 5.0 is that dependencies on certain components have now to be declared explicitly. In previous IDF releases, in all 4.x releases, with the CMake build system, you could actually include header files from the components mentioned here, driver, eFuse, ESP timer, and so on, without declaring dependency in CMake. This was actually not intended. It was just a result that some of other components, which we consider common components and components that do not require to be depended upon explicitly, like FreeRTOS, these components had dependencies on those other components from this list, and that created a transitive dependency. So because your component by default would depend on FreeRTOS, it would also get a dependency on ESP timer or driver or some other components. In practice, this resulted in difficulty to reduce the size of the build. So even if you have a very simple application, it was difficult to build just the bare minimum number of components because of those dependencies. For example, even an application that used no networking at all, it would still compile LWIP, ESP Wi-Fi, ESP event, and some other libraries. So in 5.0, this is cleaned up, and a number of those dependencies are removed. So you will have to declare dependencies on these components now explicitly, and this is done by adding these components to the requires or pre-requires list in your project, in your components CMake list file. Typically, the way those missing dependencies will manifest themselves is that you will see that some header file is not found. For example, you're including GPIO-H or you're including ESP-timer.H, and the compiler complains that it cannot find the header file. And this most likely is because of missing requirement in the build system. Another couple of small changes that you're less likely to notice, the way extra component directories variable is defined. In 5.0, this now has to be a CMake list. And actually, the reason for this change is that in 5.0, we are finally adding support for building IDF projects with spaces in the path. Previously, this was not supported, but for example, on Windows, it's very common to have a space in the username or a space in some name of some directory. So this change was necessary to support building with spaces and paths. We are also upgrading CMake to a more recent release, 3.16. 3.16 is possible to install on most up-to-date Linux distributions and on macOS as well. But if you're running an older Linux distribution, then you either need to upgrade or you need to install CMake by other means, for example, by compiling it from source or by adding some other package registry where a recent enough CMake version is available. This doesn't affect Windows users because for Windows, we always install CMake as part of ESP-IDF installation, so it's already one of the latest versions. And now on to the peripheral categories. For peripherals, a lot of drivers in ESP-IDF 5.0 have been rewritten from scratch, and this is the so-called driver NG, next generation model. The drivers that have been rewritten, they now have different APIs from the old ones. And the most important change that these APIs are kind of object-oriented. So you do no longer work with specific channels of the peripheral. For example, if you have a timer group, you no longer have to care whether you're using timer 0 or timer 1 or timer group 0, timer group 1. The driver will allocate channels so that multiple components can use the same peripheral without conflicts and without having to explicitly say which component is using which channel. It also helps when mixing projects, for example, that contain components from different authors, because those authors might not have been aware about each other and they end up using the same channel number or the same peripheral instance. Also, the APIs of new drivers are more consistent, so naming and the way configuration structures are declared and semantics of the driver, this is now more uniform between different drivers. Previously, for a lot of drivers, each driver had some unique APIs, and moving from working with one driver to the next driver, you would notice that there is some kind of different way in which APIs are defined. So this is now more uniform. The legacy drivers for those peripherals that have been converted to driver NG are still supported in IDF 5.0. For example, the timer group driver is still there, and your app can use either the old driver or the new driver, but not both at the same time. So this is, strictly speaking, makes it not a break and change, but it is an important enough change, so I mention it here as well. Typically, you will get compilation warnings or link time warnings when you use the old driver, and you can continue using it when you're first upgrading, but going further, it is recommended to upgrade to the driver NG drivers and the new APIs. And finally, a few other major changes that I want to mention. Embed TLS, which is a cryptographic and TLS library that we use in IDF, has been upgraded to a major release, 3.1. And this brings some of the breaking changes in case you have been using Embed TLS code directly. If you have been just using IDF components, then this is not a breaking change for your project, because we have already dealt with all the incompatibilities between Embed TLS 2.x and 3.x. But if you have been calling some APIs, for example, for hashing or encryption, then you need to check Embed TLS 3.x migration guides and update your application accordingly. Also removed are some of the deprecated functions and types in FreeRTOS. For example, the X semaphore handle type has been deprecated as of, I think, FreeRTOS 8. And but this definition was still provided in IDF for compatibility reasons for a long time. So now you have to use the new definitions which are available since FreeRTOS 8. That's, for instance, semaphore handle _T instead of X semaphore handle. Typically, this is pretty easy to search and replace. And also these semaphore handle T types, they are available in previous versions of ESP-IDF. So you will not notice a lot of difference in case you need to compile the project for the older IDF release. We have removed TCP/IP adapter library, and TCP/IP adapter has been a layer that, or library that provided APIs to configure networking interfaces in IDF 3.x. In IDF 4.x, we have introduced ESP-NetIF APIs, and for the 4.x releases, we have maintained compatibility with TCP/IP adapter, so you could still use it. If you have started developing your application with IDF 4.x, it is most likely that you're already using ESP-NetIF, so this change will not apply to you. But if you have a project that was started at the times of IDF 3 or earlier, then you will need to migrate. A few other changes mentioned in this slide, I will skip them. They're not very significant, and you can also find them in the migration guide sections of the programming guide. So in general, if you have some code base that you still want to be able to compile for IDF4, or if you are developing a component for other users and you want users to be able to use this component both with IDF4 and IDF5, then there is a tip how you can do this. ESP-IDF provides version macros for example, ESP-IDF version and ESP-IDF version val. These macros, they allow doing compile time checks for the current IDF version, and you can use integer comparisons like shown here. So you can check, for instance, if the version is less or greater than ESP-IDF 5. And this way you can add code that works for 4.x and a code path that works for 5.x. And then finally, when you're removing 4.x support from your code base, you can just delete this part that is in the if and if block. And similar in CMake, you can use IDF version major, IDF version minor, IDF version patch macros, variables, and you can use CMake version less, version greater than equal comparisons to compare the version numbers and have custom code in your component or project CMake list file for 4.x and 5.x. For instance, you may need to do this if you're using ADC calibration library, because previously it was in a separate component called ESP-IDC cal, and now it is in a new component ESP-IDC, which contains both the ADC driver and the calibration library. So you will have to add dependencies on this component in a different way for IDF 4.x and IDF 5. So now we are done with all the major changes. As I mentioned, this is not the exhaustive list. You can still find the complete list in the IDF programming guide, in the migration guide section. But let's now move on to the major new features in IDF 5.0. This is also, just like with the major changes, not an exhaustive list. I'm highlighting a few things that you might be interested in and that might motivate you to upgrade to IDF 5. There are 5 categories, and I'll start with the component manager. As I said before, when talking about components that were removed from ESP-IDF, the component manager is one of the most important features that we are introducing in 5.0 and which we are relying on. Actually, component manager is available in older releases of ESP-IDF as well. It's just that 5.0 is the first release where we start relying on component manager for some of the functionality. If you have a project that needs to be built with IDF 4.4 or IDF 4.3, you can also use component manager there. It is supported just the same way as in 5.0. The component manager adds 3 things that you need to know about. Component manifests. Those are the files that declare dependencies on other components, and it basically allows you to install components that are maintained outside of your project and are available either in the component registry or in a Git repository. The component manager is the tool that is used locally to install components and also for component developers to upload components to the registry. And the registry is the online service and a website where those components are actually stored, and you can find components written by other developers. At the moment, component registry is already available and contains a lot of components developed by Espressif and a few other third-party developers. Soon we aim to open component registry to all developers, so you can share code that you have written and components that you have developed with others. Component registry essentially is like a package manager for ESP-IDF. We have a talk about component manager in the developer conference. I highly recommend watching it, and it contains a lot more in-depth information about using the component manager as a project developer and as a component developer. The next category of changes or major features that we are introducing in 5.0, I already talked about toolchains a bit in terms of break-in changes, but now let's look at this from the feature perspective. Upgrading to GCC 11 adds support for C++20 and C17 language standards, and we are using those newer language standards by default. So especially C++ users should appreciate that because a lot of more recent C++ features become available. We are upgrading a lot of other tools. For example, CMake is upgraded to the latest release at the time when we are making IDF 5.0 release. We add support for color diagnostics that has been a requested feature by many users. GDB is upgraded to version 11.2, and we are also adding Python support. Previously, only GDB for Linux has been built with Python support, but now users on Mac and Windows can also benefit from Python modules. And we are actually releasing one such Python module for FreeRTOS analysis. So this is a FreeRTOS GDB plugin. You can find more information about this plugin in the list. And we automatically load it when you run IDF by GDB. So using this plugin, you can issue some commands that start with FreeRTOS, and you can look at the list of tasks, queues, semaphores, and so on. So very useful for developing RTOS-based applications and trying to understand your application in more detail. And finally, another highly requested feature has been pre-built toolchains for ARM64, Linux, and Mac. Now we have those toolchains available, and we also have ARM64 Docker images. So if you're running, for example, Docker on Mac, you will now be able to use ESP-IDF, official ESP-IDF Docker images without having to build them yourself. In the tools and build system, there have been several improvements. The installation scripts now support optional features, so we don't no longer require you to install all the Python packages that every single ESP-IDF feature depends on. This helps with installation times. This also helps put the packages that are more likely to produce some installation issues into separate features so that most developers will not have to install them. For example, one of the features that we introduced is PyTest, and it is basically if you're writing some tests for ESP-IDF applications or components using PyTest, then we have a feature that can be enabled during installation, and that installs PyTest and all the other required packages. I already mentioned support for building building in directories with spaces and paths. This probably will be appreciated by Windows users. We are just adding this feature in 5.0. It is possible that there is still a bug or two related to this feature, so we have tested it for a lot of ESP-IDF examples, but there may be some issues. So if you are a Windows user and if you want to build with directories with spaces and paths, please try it out and let us know. We want to get it working, and so that it will not matter what kind of path you use for ESP-IDF or for your project. Also, to other features that you may notice, the support for reproducible builds has been requested by many users that have multiple developers working on a project, and they want to ensure that they get the same result when building ESP-IDF by all of the developers. This is documented in the programming guide, Search for Reproducible Builds. There are some hints how to configure your application and what suggestions to follow to get reproducible builds in your case. Another feature that we are adding is the hints on compilation errors. Normally, when you build a project, if the compilation fails, then you get the error that is printed by the compiler. Sometimes that error doesn't actually tell you what you need to do to fix the problem. This is the case in the example that I mentioned earlier, and that is when you're missing some dependency on a component. So let's say you may have include ESP-timer.h in your program, but if the component doesn't have a dependency on ESP-timer component, then the compiler will not be able to find this header file. In this case, the compiler will just say that the dependency is unresolved, so the header file is not found. However, that doesn't tell you how to fix the problem, and that is by adding ESP-timer to the requirements list of your component. So this feature, hints on compilation errors, is a feature of IDF-Py, which analyzes the compilation warnings or compilation errors and prints suggestions how you can fix this. So over time, we will be including the number of hints that IDF-Py knows how to print, so we can give you recommendations how to solve certain compilation errors and get on with your project faster. So for a lot of break-in changes that have been mentioned before in this talk, We have already added those hints. So you will see this as a yellow or orange text added by IDF-PI at the very end of IDF-PI build output in case compilation has failed. I already mentioned the driver NG, so the new set of drivers that we have introduced in IDF 5.0. This is just some subset of drivers, so we will be adding more drivers in this driver NG model in future releases of ESP-IDF. And also in 5.0, we have added some of the examples for certain features that we didn't have previously. USB host is one such case. There are new examples for mass storage, USB video class, and CDC that you can find in IDF examples folder. Actually, these all examples rely on external components that are maintained outside of ESP-IDF and are installed using the component manager. And now, finally, a few other major features that we have introduced in 5.0. We have a preview of Amazon FreeRTOS SMP kernel. There was another talk about FreeRTOS at the DevCon. If you haven't watched it yet, highly recommend doing this. It goes in depth about different versions of FreeRTOS kernel and our plan to migrate to the latest Amazon upstream SMP version. This feature is now in preview, so you can enable it in your project, try it out, and then let us know if you find some issues. We plan to move to the SMP version of FreeRTOS by default in one of the future releases. We also have now the support for tracing over UART. Previously, this was available only through JTAG. AppTrace and System View features, which System View depends on AppTrace, can now work over UART. So if you have a spare UART and you want to enable tracing, but you can't use JTAG for some reason, then you can get a fairly high-speed System View traces if you have a high-speed enough external USB to UART adapter. Another new feature is the tool to create FAT file system images. We already had a tool to create SPIFFS file system images and NBS images on the host. So now we are complementing this with a tool to create FAT file system images in case you prefer to use FAT file system and not SPIFFS. This tool, just like the one we had for SPIFFS, allows taking a directory with files and creating a file system image that will be flashed to the FAT partition in your device when you run IDF by Flash. We have another talk at the developer conference about this tool, so watch that if you're interested. Pre-encrypted OTA has been a highly requested feature, and ESP-IDF now has an example for handling OTA updates when the update that is downloaded from the cloud is already encrypted. Something that you might not notice if you're just using ESP-IDF as a project developer is that we're switching to the PyTest embedded test framework. PyTest embedded is a plugin for PyTest, and this test framework allows us to write very concise test cases for the behavior of the embedded application. In IDF, if you go to examples folder, in many of the example folders, you will find files that have PyTest in their name, and those are those PyTest test cases. Although this is a feature that we primarily have developed for our own use in ESP-IDF and other projects, you can use it in your project as well. So if you want to test your application or test your components, then you can also use PyTest for this. We have a separate talk about testing in ESP-IDF and how you can apply it for your projects at DevCon. So again, there are more details there. And the last feature I want to mention, that is the board support packages. This board support packages, they are components that, again, are distributed using the component manager. So you see that component manager is indeed one of the features that gets used in 5.0 a lot. Board support packages, they allow you to get started with some of Espressif's development boards really easily by providing you out of the box the drivers and all the header files with bin definitions and some helper functions in a convenient package. So if you get, for instance, an ESP box or Kaluga kit, it comes with a lot of peripherals, and now you can simply install the board support package for this development kit using the component manager, and you will instantly get all the required drivers for this board. There are many other major features in ESP-IDF 5.0, so I encourage you to take a look at the release notes of IDF 5.0 and see if you find something interesting for your project there. Finally, I want to very briefly mention the future plans we have for the next IDF releases, IDF 5.1 and later. As you probably expect, we will be releasing new chips, and next IDF releases will come with support for those new chips. We do want to improve the way release notes are presented and how we track bug fixes across releases. This has been a thing that a lot of users mentioned to us on our GitHub issue tracker. So it is at the moment pretty difficult to see whether the fix that is important for your project has been already backported to one of the older release branches, and we want to improve this process and make it more transparent, and so that we also don't forget to backport those fixes to the releases where you need them. More drivers will be converted to the driver NG model, so APIs of those drivers will also be unified. More components will be available outside of IDF, and you will be able to install updates for those components without having to upgrade the entire ESP-IDF, so just by upgrading certain components. And this will use the IDF component manager. And we do plan to enable Amazon FreeRTOS SMP kernel by default in one of the subsequent releases. At the moment, it's not clear which release it will be, but anyway, I encourage you to take a look at this feature and try it for your project and let us know whether it works for you. And with that, thank you very much for the talk. I hope it was useful for you to learn about ESP-IDF 5.0, and you will be able to efficiently apply ESP-IDF 5.0 in your project. Now I have some time for the Q&A.